Hello, I'm Susankar Kandi from Alma. Today I explain my second caption project, Module 2. In between 25 problem, I choose 5. Let's move on to my first problem. My first problem is the power of 2 puzzle. In this problem, I found two error or operator and operator. Let's explain my project. Explain my solution. N greater than 0 is ensure that the number is positive. The power of positive integer, so n must be greater than 0. N and n minus 1 equal to 0. This check whether n has exactly on bit set to 1 by subtracting 1 from n. We flip all the bits after the first one. The bit is and of n and n minus 1 should be 0 for power of 2 because the only one in n while not have a corresponding one in n minus 1. If the condition is true, then n is a power of 2. Otherwise, it is not. Let's move on to my second problem. My second problem is guessing happiness through number. Guessing happiness through number. In project description, already given a approach, I explained my given already given an approach while you use hyperfunction to calculate the sum of square digits. Let's explain my second approach. I use also hyperfunction to calculate the sum of square digits. Let's explain this. And in this solution, okay, a set to keep track of number we have seen. Hyperfunction calculates sum of square norm. Compute the sum of square of each digit now. Using the set, initialize an empty set called sin to track the number encountered. While n is not 1 and has not been seen before, add the current number to the set. Update n to the sum of square of its digits using calculate sum of square now. Checking happiness if n become 1, return true, the number is happy. If we encounter a previous seen number, return false, the number is unhappy. Here is my solutions and explanations. Let's move on to my third problem. My third problem is peak elements. Let's explain my solutions. In best case, when left equal right, we have found peak, and this a peak must be on the left side, introducing mid. In each case, in all the else case, a peak must be on the right side, executing mid. In this scenario, compare mid with its next element to decide the direction. In this solution, we started by initialization two pointers. Let's left zero. This pointer start at the beginning of array. Right sum dot length minus one. This pointer start at the end of array. This pointer helps us define the current search range within the array. Binary search loop, while left less than right, the loop condition running as long as the left pointer is less than the right pointer. The condition ensures that there are at least two elements in the current search engine, allowing users to divide the range. It's all about. Let's move on to my next problem. My next problem is missing number. In this problem, I have two approach: traditional approach and optimized approach. In traditional approach, are all elements of array to the state, and in the follow, if the integrate is not in the state, it is the missing integrate. And the optimize unless the optimized approach, the time complexity of this approach is O(n), since it involves uh, swimming the element of the array and calculating the exact sum. Space complexity, the is 0, 1, since it only uses a few extra variables, total sum and array sum. The optimized approach leverages the formula for the sum of first and natural number. Total sum n into n plus 1 divided by 2. The sum of array sum is completed by integrating through the array. The missing number is the difference between the extra sum, total sum and the actual sum. And in traditional approach, the time complexity of this approach is O(n) for interest element into the set and O for checking each number of 0 to n. Thus, the overall time complexity is 0 to n. Space complexity in this approach is O(n) due to the use of hash set to store the element. Here is my problem and explanation. Let's move on to my last problem is binary of Wheatland. In this problem, we analyze worst case scenario and the best case scenario. In worst case scenario, integrate through each pair of element in the array, compute the bits and AND of each pair, keep track the maximum value obtained. In best case scenario, sort the array in depending order, compute the bits and only for adjacent pair in the sorted array, keep track the maximum value obtained. In worst case scenario, for the brute force method occurs with large array, as the time complexity is quadratic O(n) to the power of 2. In best case scenario for the optimized method involve array where sorted the computing adjust element is efficient giving a time complexity O n log n, and in the it's all about my project, and, and thank you.